Hello, hello. Hello and welcome. So recently, a Udemy course that I created celebrated having 6,000 students. So I've spent some time to add even more content to that course, and I'm going to go over it today. So I'll explain a little bit about what the course is, what the course content and technology is, and feel free to jump in. The source code that I'm showing is all freely available on Git. You can find the link here in the description below, and I'll add it to the chat in just a second. Actually, I'll do that now. So the course here is up here. There we go. So I'll add that into the chat. There we go. So now the chat has both the Udemy course itself, which is a paid course, and then has the related Git repo, which is completely free. So if you want to follow along with the Git resources, great. What I wanted to do in this talk is go through some advanced topics and advanced demos that I've created. So we'll go through them one by one. I'm calling this more content because some online educational platforms, including Udemy, have a very specific meaning when you say bonus content. That's what I wanted to call it, but bonus apparently means something very specific. So more content is coming. This is all already committed to the Git repo. Some of the students who've been digging around in there have probably already played with some of this stuff, but we're going to go through it one by one. I'm not going to talk about the MVC fundamentals. Really, that's what the course is there for. So you can watch the video preview on the Udemy page, which is linked in chat, if you want to see a bit more about that. Really, what I'm doing after this live stream is I'll be editing up this video and including it in the Udemy course. So feel free to learn as we go here. I've prepared a few slides here that we'll step through. Really, they're just to remind me what topic we're on, to remind you what the benefits of the course are. And you will find, if you follow along in the stream, I'm going to repeat some of that content because, again, later I'm going to slice up this live stream into smaller bits so that you can jump right into it. So thanks for coming along, and let's see what we got here. So this is related to the MVC Architecture for Unity course. MVC stands for Model, View, and Controller. When you're architecting Unity projects, one of the challenges you have, I would say when you hit around the 200-hour mark of playing with Unity, so let's say that's 3 or 4 weeks of full-time development, you'll probably see that just putting code in any old spot within the project becomes problematic. Then, if you're using Unity for 2 or 3 years full-time, even on production projects, you'll find that even as the best minds come together and work on projects, bringing some best practices to it, it still becomes a challenge to organize your projects in a way that can scale, that can be testable, that can be maintainable. So there's lots of off-the-shelf solutions as well as custom solutions you can do. In this course, I talk about all that. And then I land on the MVC pattern, a historically popular pattern in software development and games for, let's say, 30, 40 years. I lean on that as one of the leading choices, and then I dig deep into it. I also show a custom framework that I created, which we'll go over here today, called the Mini MVCs framework. So model, view, controller, and then the S stands for service, which is when you're dealing with calling external data, backend services, et cetera, and stuff like that. So in the course, if you choose to grab that course from Udemy, it's on discount today and forever moving forward because we're celebrating having so many students. In the course, there's course introduction. I go over everything about Unity. So if you're new to Unity, you can take advantage of that section. This is a pretty advanced topic, so the course is probably best met with somebody who's got a couple 100 hours of experience with Unity. So to think about that, that sounds like a big number, but that's 3 weeks full time or, spending nights and weekends for a year on it. A lot of hobbyists will reach that point pretty quickly. If you're brand new to Unity, this may be too challenging and you might want to come back to it when you have the fundamentals there. The course itself on Udemy explains what those prerequisites are. So in the course, we have talking about Unity, as I mentioned. Then I go over software design, some of it related to gaming and some of it not. That's design principles, design patterns, doing UML diagramming, which is a way to explain your ideas visually and simply using some sketches, and then the different architectural approaches for Unity. One of the things that I did in preparation for that was I made a simple 3D bowling game in Unity, and I did it 6 times. I did it once, starting with what I believe is the beginner's approach, where you put bowling ball code on the bowling ball and pin code on each of the 10 pins, and you start the project that way, kind of thinking wherever the visual element is, that's where I'll put the code, all the way up to using MVC and the 6 different approaches between the two. Then I look at MVCS as one of the solutions here. Then I introduce my custom framework that I'll show today. And then I go through in the course 4 different sample projects, 3 of them that are off the shelf. And then I create a custom sample project during the course. So if you really want to dig in and learn everything about what is the problems of scalability inside Unity and how you can solve it, this course is a fantastic way to get into it. I'm going to start today really building on top of that. So take it for granted that you may not understand all the concepts if MVC is new to you. I'm hoping you get excited about this live stream and then jump in and want to get the course. So what I'm going to be showing is more demos on top of it. So here's all the demos I'm going to go over in this stream. We'll see time permitting if I can get through them all. For each of them, I will run them in Unity, see the result, then I'll step through the code, and we're going to repeat that. Probably, even if you're kind of new to the concepts of MVC, you'll be able to start seeing the patterns as I go through each of these examples. I'm going to try and spend 5 minutes on each of the examples, but I'm not exactly sure. I may need a little bit more time. And let's see if I can get through all 3, 6, 7 examples. I actually have an 8th one, but let's see if we can get through these ones here. So if any of these topics are interesting, UI toolkit, how to build an in-game tutorial, when you want the player to be guided through their first 5 minutes, learning the keys, etc. How do you exactly add that into a game? Then an approach of multiple minis. So once you get used to the MVC architectural concept, we usually think of having one of those in the entire project. But what if you actually want to break your project and have more than one mini in it, which you definitely can. I'll talk about data binding as well. So if you want to have a text field in your UI and then map that to where your data is stored, and anytime you have the user update that text, it'll automatically update the data model, and the reverse. Anytime the data model updates, it'll update the UI. So looking at data binding. Unity doesn't natively support that. Quite excitingly, that is available in UI Toolkit for Editor now, and in the future, it's coming in Unity for runtime. I'm very excited about that. This is a custom approach that does some data binding. Then we'll look at a simple game, this bouncy ball game. And then starting from the top, we'll look at a calculator, and this count up example is very introductory ways to take a look. So we'll start from the top there with the calculator. So let's jump into Unity here. So here is the project that I've linked into the chat. You can see there is a Git repo, and there's instructions on how to install that Git repo. After you've done that, you'll see in the package manager, you're following the Git instructions, you'll have this package installed. This is the RMC Mini Mvcs. So RMC is my consulting company, Revela Multimedia Consulting. All of the packages that I release have that name. And then the Mini MVCS concept is Model View Controller Service, and with just a very light footprint. So it handles the most basic common workflows that you'll encounter, including everything we're looking at today is built on top of this tech. And it's Mini because it's quite elegant, lightweight, etc. Then under the samples here, you're going to want to click samples and import. I've already done that, so we're going to go look over it. But again, the README explains how to get those samples in there. So let's start with our first one here. We're going to close a few things here just to get us ready here. Then in the project, in the assets, we have the more folder and we're going to step through them. So we'll start from the top and look at this calculator sample. Now, all of the MVC structures, we organize the folder structure to mimic the MVCS pattern. And every once in a while, I'll just make sure that I have my video on the correct side. For example, I can bounce myself over here. Sometimes I might be covering stuff up. Just know if and when I catch myself doing it, I'll pop myself back over here. So again, here's the structure. We have a folder for model, view, and controller. And let's open up one of the parent folders here. And here we're looking at it. I'll try to be aware as I'm showing the code here of having the code be presented about 25 lines high so that you get quite a bit, but it shouldn't underlap my video here. So let's talk about this. So this is the mono behavior that sits in the scene that kicks off the entire project. If you're familiar with Unity, you know that at the very least, you'd have one game object in the scene with one mono behavior on it, and that's where you kick off your project, game, demo, etc. So here we have that. And all I do here is I have a serialized field to grab the view, which is a separate game object, just to separate the concerns. And then in the start method provided by Unity, I create the calculator mini. So anytime you see one of my classes called mini, that's meant to be this parent object. And typically in these examples, there's exactly one. So here all I do is take the view in, pass it into the mini, and initialize the mini. Now let's run the demo and see exactly what happens here. Make it nice and big for us. So here we have an A field, a B field, a result field, and then we're able to add them together and reset them. Notice that add and reset are grayed out because you haven't inputted any fields in here. So there's some very light validation done. Let's say we wanted to add 2 plus 3. Now the add button is available and we click them and the result is 5. I can click reset. I'll choose 5 and 10 and click add again. And we see the result is 15. So we have the UI shown here and then some sort of calculations being done on the UI. And then those results of the calculations go back to the UI. So very fundamental classic example of doing MVC here is to divide up what, as a beginner, you might make one class that does all of this, has the views, has the UI, does the calculations, takes the user input, reflects it out there. But on a larger project, that would become unscalable. So let's see how we set up this scene here. So we've got, in each of these scenes, we have a world game object, which is just an empty game object that has a couple children in it, the camera and the lighting. So I just hide that since it's the boilerplate basic stuff in every single scene. Then we have the calculator view. Let's take a look at that. So that is using Unity UI, which is the most popular UI system that's been around for years. Not to be confused with UI toolkit, which is even newer, but this is your standard UI. And we've got the different UI elements. We have the event system. It's all pretty boilerplate stuff. And then here, I will pop myself over here. So we have the calculator view script, and that is just one custom script that I've added that takes each of those UI elements. So what I do with that is just store them there and then be able to get access to them. So that's how the view is set up. Then as I mentioned, here's the example itself, and we're drag the view into that. So anytime in Mini MVCS that you want to have a view that extends mono behavior, which is a super common but optional pattern, then you want to have that be able to be accessed by the Mini itself. So you pass in the reference to the view into the example. So again, here we were in our example. Here's the view. Here comes the Mini. Let's take a look at how that's set up. Again, each time, getting a little wild with our zoom here. Okay, so here is the Mini pattern. It extends the built-in Mini MVCS. Here in the constructor, it takes in that view. Then in the initialize, it creates a context. Now, context is the glue that has the model, view, and controller communicating into the same system. If you had multiple contexts, you would have multiple minis. But typically in our projects, including this one, we have one mini, which means we have one context. You can think of it like the little radio channel that gets all these 3 different concerns to talk to each other. So we create a context there, just creating the simple context there. Then we create a custom model that's going to hold our specific values here. We create a specific controller here. Controllers are the glue, again, that get the business logic done. So I take in a model, I take in a view, and are able to have the two of them talk to each other. And then, as is the standard pattern with this, what I do is I initialize everything explicitly. So you can see here, we create the context, we create the model, we create the controller, and then after all that, we initialize each thing. Typically, it's at the initialization phase that stuff really starts happening. If I didn't initialize them, they would sit there, perhaps connected together and ready to do things, but wouldn't really kick off their process. And as I mentioned here, often the order of initialization is important. So I have to initialize the model, the view, and the controller. And that's not an explicit rule across all projects, but you'll find that depending on which the dependencies happen, you'd want to have them start kind of in the simplest and easiest to initialize. And typically your controller is initialized last. So cool, let's take a look at each of these. Here's the calculator model. So the model in the MVC framework, it's your dumb data storage. So here I'm storing the A, B, and result that we saw in the view. Now, I use a custom class that I've created that's included in the Mini MVCs called an observable. So anytime you see observable int, just think that that's a regular old Unity int that's meant to store whole numbers, but it comes with a little bit of extra power that can dispatch events and be listened to and do a little bit of data binding. So here I'm storing 3 different ints, and then I initialize them all to 000. So that's it for the model. Now we're back here. Let's look at the controller. Controllers tend to be a little bit more complex. So here I am using the interface iController. I have a reference to the model, which we just looked at, and the view. I store them here. And then in the initialize, what I do is I listen that anytime the add button or reset button are clicked, I listen back to that. And let's look at what the consequences are. Well, anytime the controller here hears the view button has been reset, then what we'll do is we'll reset the values in the model. Pretty simple, straightforward. Anytime the add is done, here the controller's actually what does the calculation. So it's going to say A plus B is the result, and that's it. Now, notice here again, because I have the A, B, and result are of a type observable int, you always have to do dot value to actually set them. So you can take a look at the source of the observable int in the free Git repo that's linked in the chat. But you'll see that the powerful thing here is that anytime you set that value, an event is dispatched, which any system can listen to. So again, we're starting to talk about some light data binding there. So that's it. Now let's just talk about the view, which is the last thing that we haven't looked at. So we'll go up here to our reference of the view. All right. So the view, it extends mono behavior. So there's no rule that any of the MVCs concerns need to extend mono behavior. It's up to you. Each of them or all of them or none of them can extend mono behavior, but it's very common that the view extend mono behavior. And that's because typically the view deals with taking user input, showing and rendering graphics to the user. And in the Unity world, having a mono behavior helps that stuff happen. So here I create some Unity events for when the add and reset button are clicked. There's some setup here. I listen to the UI elements. So I'm using Unity events here to listen for when these text field changes. Anytime one of these text field, anytime the model value changes, so here I'm listening to the A, here I'm listening to the B, and here I'm listening to the result. Anytime that those change, then I just update the text values. So this is our two-way binding. If the user types into the input field, that gets listened to here and sent to the model. And if the model ever gets changed because of the add or the reset, then it passes it back to the view. So that's where we're doing our data binding. And down here, I do a little additional step to gray out the reset button and gray out the add button. If there isn't any valid input in the fields, then I just check that here. Anything else to see here? Yeah, I guess when the user clicks the add button, then I dispatch the add a custom event. So let's run the demo again. I'll make it nice and big. And oh, maybe I was covering up code for a lot of that. Whoops. We'll just try and pop myself on the right side here. So let's try 1 + 1, and then I'll hit reset, and 2 + 2, and I'll hit add. So there's the result that we have there. So that's it for the calculator demo. All right, now let's take a look at the count up demo. So this is a demo created using the Mini MVCS architecture for Unity. You can check out the Udemy course if you want to see all of the teachings about how and why architecture in Unity is challenging and why the Mini MVCS is a great community-driven solution. Then also the framework itself is freely available, so you can check out the link and you can just play with the source code if you want. So this is built on the MVC architecture concepts. There's a Udemy course which goes over the following content. The course introduction, I talk about Unity, I talk about software design, and the Mini MVCS framework for Unity. Then deeper, more information about each of those topics here. You can see that there are sample projects included, but today we're going to go over some more demos. In particular, we're going to look at the count up demo. So let's go ahead and take a look at that. Here I am in the Mini MVCS project. When you download and install that, you can go here and click samples. So Mini MVCS and then samples, and import those samples. I've already done that here. So we can look at more, and let's look at count up. So I will start by running the demo. So here on the screen, it's a little small. Let's see if we can go like that. There we go. It's a little bit bigger. So this is meant to be the simplest demo included in the course. So we have some view here that says text count up, mini example. And then there's a counter button that shows number 23. I think I start at a non-zero value just because I load from a service. Then we can click here, and if I click anywhere on the screen, it goes up as I click it. Let's stop and start the scene again. It always starts at 23, and then we'll click up. So we'll look in the code, why does it start at 23? So that's it. Taking a click, showing it on the screen. Now, you don't necessarily need a complex architecture for this example. You could probably get away with one mono behavior then and make this whole example work, but it's meant to be an easy way to onboard and understand the fundamentals. And then imagine bringing them to a game like Fortnite, right? That's much more complex, and you'd want to learn these basics here. So let's take a look at how the scene is set up. So we've got a world game object that just has the camera and the directional light, nothing interesting happening there. Then we have a Unity UI canvas here with our title text and our status text here. Let's zoom in on those a little bit. There we go. There we are. Then we have the mini example itself. So this is the mono behavior that kicks off the demo. It creates the mini itself, and it brings in the view and the controller concept. So let's take a look at it. Let's open up that source code here. Just make sure we have. And unlike earlier demos, I'll make sure that I'm not covering up the interesting code here. There we go. So here we are at the top. This is the mini example that's kicking everything off. I take in a serialized field of the view. So let's look here. We have a serialized field of the view, and we drag in the view just like this, and then it's in there. Back to the code. All I do is create the count up mini, which you could think of as the app itself. This is the most parent structure here, and I pass in the view, right? So anytime we want to have a view in the scene, we usually do this pattern. Serialize it, pass it in this way. Then let's take a look at the count up mini code. All right. So the count up mini is going to extend the mini MVCS, which is going to have these parts in it. It's going to have a context, which is the communication between the 4 tiers. It has the model, which is the data storage. It has the view, which is what renders to the user UI and what takes input back from the user. The controller, which is going to handle any business logic, the meat and potatoes, the bulk of your code would probably be in the controller. And then the service. Service is optional, and it's only needed if you want to call any external data. Loading a file from your local machine, calling an online backend service, for example. Down here in the constructor, I just take the view and store it. Then in the initialization, I create a new context. Context, again, is just a low-level object that's required part of this. Then I build the model, the service, and the controller. Now, as quite common in these examples, the controller will take the other 3 tiers inside, and it's really the controller that does most of the work. So what we're looking at here is the mini, but the mini just really prepares and feeds the controller, and the controller is going to do most of the work. Now, a common question is, well, do you always have exactly one model, view, and service controller in your project? And you could have many, many more. So imagine this mini here setting up the player model, player service, player controller, and that working on its own, and then having the metagame model, metagame service, and metagame controller. Metagame is often where you have your game services connecting things to the backend, allowing the user to store their progress, connect with friends, all those social features, being able to share things that way. So you can have each of those areas of your project be separate minis or separate controllers. So then you see that they all get initialized here. So now let's just step through and look at each of these 3. So in the model, remember all we're doing here is clicking the screen and seeing a number count up, 23, 24, 25. So we just need to store this int. You could store them as a simple int. I use something in all of my demos called the observable int, which is an int that also dispatches an event anytime it changes. Very useful for data binding. In here, all I do is set the value to 0. Now remember when we run the demo, it starts at the value of 23. So we still haven't seen why it starts at 23, because here it looks like it's going to start at 0. So then let's look at the service. The service is going to inherit from base service, which is optional. Anytime you extend from the base classes, it is optional. But what we want to do here is use the base service because this is going to kick off some interesting stuff for us. Very lightweight, but it's convenient. Then down here, we store a value, and it's here that we get that value 23. So we're going to load a local text file, and then whatever the value is that we load from that local text file, we're going to dispatch it to the model. And if I was to go look at this text file, let's go do that right now. Resources, text, count up text. We can see it starts at 22. So I was saying 23 before, but it starts at 22. So that's why it starts at 22 if we tweak this value. Now, this is a silly example. Why would your data model, why not just hard code the value in C#? You certainly could. But here I wanted to show an example of what a service is. A service loads any external data from local files or from backend services. So that's it there. That's the service. Now let's look at the controller. This is the most complex part. So the controller is going to extend from base controller. As the comment said, extending from base is always optional. We do it here again because there's a little bit of common boilerplate code that's done for you. Then the controller here in the initialize is going to set the UI text. Then it's going to load that service that we just looked at. Then when the service gets loaded, it's going to set the model counter value to whatever the service just loaded. So the service goes and gets the value 22, it passes it to the model, and now the model has that value as its initial one. That's why it starts at 22 and not at 0. Then we listen for any time anywhere on the screen is clicked. And if the screen is clicked, let's go down here, it just increments the model by 1. And that's really it. So let's run the demo one more time. So it's still, I guess somewhere I'm adding, oh wait, actually when I clicked on the screen exactly, just to load the scene up here, that's why it's loading one more. So it loads 22, I click the screen, it shows 23, and that's the demo. That's it for this demo. All right, here, let's take a look at the bouncy ball demo. I'm a little bit in front of the word demo, but there it is. So this is part of the Mini Mvcs course. This is a Unity architecture course that's available for purchase. And all the code we're showing here, including the full code for the course, is freely available on GitHub. So you can take a look at that, the link below. This course is about you doing architecture inside Unity, the model, view, and controller. In it, we'll cover the course introduction, we'll talk about Unity, we'll look at software design. Let's take a look at the next slide to go even deeper. In software design, we look at design principles, we look at design patterns. What are those things? We look at ways to diagram our designs with UML. We look at all the different architectural options for Unity, and then we land on Mini MVCs, which is a custom free architecture as the leading solution. Then there's 4 different sample projects included in the course, but today we're going over even more demos besides those. I think I've added 10 more. So we're gonna go over the bouncy ball demo here. So let's take a look at that. So here I am in the sample project. If you've gotten the sample project here, the Mini MVCs, and followed the instructions from the Git repo, then come into the samples here and just import those samples. Now I've already done that for us here. We can see the samples, and we can see here in the more folder, there is the bouncy ball mini. So let's look at those. And here's the demo. So let's just run the demo just to start. It's a little bit of audio playing. I'm not sure if you can hear that. But all it's doing is using Unity physics to bounce a ball on a surface, and then it updates the UI. Now, there's no interactivity in this demo. Actually, I think I can hit spacebar if I remember. No, there's no interactivity. So all it does here is run on its own and use some physics so you could take a look at how that physics interacts. And you can see that the UI is getting updated there. So let's take a look at how this is structured. So here in the scene, we've got a world game object that just hides the camera and light, which are not too interesting. Then we have the bouncy ball view, which has all the graphics that we see there, and also the UI. So let's just look at the UI elements. It's got the title and status there. So this is, the view contains everything we see visually, and the view also plays the audio. Now, I'm not sure in the recording if you could hear the audio, but it's just going bounce, 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 and playing a little noise there. So that's it for there. Now let's take a look at the example itself. So this is a mono behavior called the bouncy ball mini example. And all I do is drag in the view as the only reference that it needs to take here. And then this is off and ready to go. So let's look at the source code here. Zoom out a little bit here. So here's the example. The example is going to take the view in as a serialized field. Then it is going to just start, in the start here, it's going to create a new bouncy ball mini and pass in the view. So mini here in this terminology is the wrapper for the entire app. So anytime you see mini in the source code, it's meant to be the most parent structure. And inside of it, it has several elements, including the view. Let's take a look at that next. So opening up the view is going to extend, I'm opening up the mini to start with. So in the mini, I take the view element. It also has an audio controller there. And here's what we do inside the mini initialize. We're going to create a context, a model, controller, service. And it's going to wire them all together here in this one line. So anytime you see the controller getting initialized, in the mini world, the controller is the most, let's say, most knowledgeable concern in the whole system. So the mini itself has 4 parts inside. One of those parts is the controller, and the controller is the most knowledgeable part. So it takes in a reference to the other 3 concerns, and it's what will say, hey, data model, what's your value? Hey, view, did anybody interact with you? Hey, service, can you load something for me? It's the controller that's going to glue all that together. So let's look at the model quickly. The model is going to hold values for how many times have we counted up, and what is the maximum. So it's going to say 1 of 3, 2 of 3, and then when it reaches 3 of 3, it's going to reset itself. 1 of 3, 2 of 3. So that's how those 2 values work there. Here, notice that they're both set to 0. So we'll take a look at what sets the max to 3 in a moment. Now let's look at the service. So the service layer is what is meant to call any external data. If your game does not need any external data from the beginning or ever, you can omit this step. You don't need to have a service. But typically today's games call backend services, local files that are external to the game itself, like we see here. And this service concept is a great one for that. So here, all it's going to do is it's going to load a local text file and then parse that value into the bounce count max. So let's look at this text file. It's here in resources, texts. If I open it up, it starts with the value 3. So it seems a little silly here that you would have a value. Why not just hard code 3 in C#? This is just an arbitrary demo to show, let's put some data outside the app and go load it. I could have also loaded this from the backend, for example. So that's it for the service. It's just going to go load that value 3 and pass it back to the controller. Now let's look at the controller. This is the last thing that we need to look at. In the controller here, we inherit from base controller. As the comment says here, let me move out of the way. Always base is optional to extend. It's just going to give you some free functionality. But you can begin to see through these examples how few lines of code there are to get this architecture set up. Well, I say that. Also, someone looking at this example could say, hey, I could bounce a ball with one mono behavior. Why do I need these other classes? But again, the example here is we're learning fundamentals in a very simple use case. Now imagine growing your project up to the size of Fortnite, managing multiplayer, metagame, each of the players, all of the things you can do with your player. We would have thousands of classes and tens of thousands of lines of code. Having this best practices divided into model, view, controller, and service really pays dividends on your projects. That's why we're starting so simple. So it's a common concern when people are getting into learning architectures. It feels like, hey, that's a lot of classes or a lot of lines of code to get simple things done. It's true, but you're paying in some investment time now to learn these fundamentals. So as your projects scale, you're set, right? It's a wonderful thing that 3 months into a solo project or 2 weeks into a 5-person project, there is not a question of where the next feature should go because you guys are all working together on the same architectural pattern. And you know, hey, a button click, well, that's going to start in the view, and that's going to then go to the controller and then go to the model. You're speaking the same language. So the Udemy course talks about the benefits and the cost benefit analysis of bringing on new tech like this, Mini MVCs. So back to the controller here. What we do is we initialize the view with some text fields. We go listen to that service here. And then whenever the service loads, we take that value we loaded from the text field and we pass it to the model. Then we listen to the view and we say, hey, view, anytime the physics detects the ball has bounced, then let's capture that here. And we'll update that listening anytime that the bounce count has changed here. So there's a little bit more to look at here. You can dig in. We also have a little bit of the command pattern, which we'll look at in a future example. So let's run the demo one more time. Yeah, I can see that the mic is picking up the bouncing. So it just goes 1, 2, 3, 1, 2, 3, 1, 2, 3. That's it for the count up demo. All right, next let's take a look at data binding inside Unity with a custom architecture. So this is the data binding demo off to the side. So in the data binding demo, we're going to see how in a project that has MVCs added, how would you have data binding? Now, data binding is meant to have an easy, reusable pattern to sync values across different domains. So if you have two classes and they both have a message text value, and you want, if one of them changes the value, for the other concern to hear it. And if the first one hears it, then it changes it, then the second one hears it. So having two-way binding. So let's take a look at an example. You can imagine how useful that would be. Now this demo is part of the MVCs Architecture for Unity course, which you can find the link for below. It is a paid course and it's on discount now because we're celebrating having over 6,000 students already. Hopefully by the time you watch this, you'll see even more students there. The course itself covers all sorts of different topics, Unity, software design, Mini MVCs as well. And in the extra content, we've added 10 more demos on top of what was already there, and we're going to go over one here. We're going to look at the data binding here. So let's go ahead and take a look at the data binding by jumping into Unity. So here inside Unity is the project. If you follow from the free Git link that has the whole source code, you can bring in the package with the instructions there, and then you'll just go to samples and click import. Now, I've already done that here for the sake of this course. Let's go to the more folder and look at the data binding example. So let's take a moment and look at the data, the structure of the folders here. So inside data binding, I have a folder for with Mini. Because some of the earlier demos, I have a version without Mini, if you want to see a traditional approach in Unity, and then with Mini. This one, I only have it done with Mini, which is what we're looking at here. Then in the resources folder, I've got a couple prefabs here for the two different views that are going to be in the app. I've got the scene, which I'll run in a second, and then I've got the source code. Now, as is common with these demos and best practices for Mini MVCs, whenever you run one demo in Unity, you want to structure it so the source files for controller, model, view, and service, if you have it, have their own dedicated folder. That way you can easily see the different separations of concerns. Cool. So let's run the demo here. I'll make it nice and big. Now let's take a look at this. So here we have two different views. You could think that this is part of one layout, but they're actually two prefabs. So we put them out there, and we want to be able to edit this one here and say, hello world from the left. And notice both text fields get updated in real time. Let's go over here and then say, I am on the right. And you can see that both get updated. So we have two-way binding in the MVCs. So let's see how that's done. Now, as I may have mentioned in an earlier part of this video series, Unity historically did not support any two-way binding. Then they've added it in the editor for editing tools. And in the future, it will come to runtime, especially as part of the UI toolkit. So I'm not using UI toolkit here, and that feature for runtime two-way binding by Unity is not yet available at the time of this recording. So I've done a custom solution here. So let's take a look at that. So here in the scene, I have the world, which is a game object that just has the camera and lighting in it. Then I have the left view, which if I move the left, why can't I move that? All right. And then we have the right view as well. And then we have the data binding example. Now the data binding takes a reference from the left and the right view. So let's start our code journey here. So here's the mono behavior that is an example running the entire scene. I have the two serialized fields we just looked at, the left view and the right view. And then in here in the start, I'm going to create a new context. Now we haven't seen this in earlier demos, and in the heart of the course, we don't show this exact workflow. But here I'm creating the context outside of the mini, and I'm passing that in here. And then I have the left view and the right view. So I create it outside and I pass the same value into each of the concerns. Oh, actually, now that I think about it, there's a different demo where I have multiple minis in the same project, and this is borrowed from that. So creating the context outside of the mini is not explicitly required here. It is for the other demo called multiple minis, which you can take a look at in the series. So this comment is not necessarily required here. Now, let's go ahead and look at the mini. So here, what I do is I have the data binding set up in its own mini. And the mini here is going to take references for the left view and the right view and store them. Then down here in this is the initialize of the mini. I'm going to set up the model. There's one model. I'm going to set up the view. There's two views, a left one and a right one. So again, notice that they're distinct, separate user interfaces. And then I'll have the controller here. Now the controller is going to take a reference to the model in both views. And as with all minis, the controller is the smartest of the concerns. So it takes a reference to the different parts, and it's the controller that's going to be able to have them working together. So here's the controller. I think this is the only concern we'll take a look at here in this demo. I take the left and the right, I store them here, I store the model. Then down here, I was expecting there to be more logic here. Let me think about this for a second. Yeah, I guess I created this a bit ago. Often, what I'm about to show in the views is how they do the syncing. But you could do the syncing of the two values for the text field on the left and the text field on the right in the controller. So I was kind of expecting to see it here. But let's go take a look at the other concern. So here's the model. And the model in MVCS is the dumbest of the concerns. So if controller is kind of the smartest, the most aware, it has the context of the kind of the whole situation. Models are on the dumber end of things. It just stores data, and that's it. So here it's going to store a string of message, and it's going to start with that initial value we saw that says edit this text. We'll run the demo one more time so you can see that being set. Then let's look at the left and right view. So here's the left view. It's going to use mono behavior, as we often want to do for UI related concerns. It's optional to extend mono behavior in Mini, but here we want to do it. And then down here is where the binding is going to be. So let me make sure that this is on the screen in a nice spot. So again, we are in initialize. I just want to be able to make plenty of room here to talk about it. Okay, so the first thing I do is I set this up. So what I do is I have a reference to the model. Now, in MVCS, The controller can always access the other concerns. But as a best practice, you want to limit the access from other model, for example, to view and view to model. You want to be very aware of those. Here I'm making a conscious choice to actually have the view, which is the class we're in, get a reference to the model. And the way that you can do that is by asking the context, which is implicitly available for you, and say, hey, model locator, go get me a reference to the model that's in the game. It looks a little bit like dependency injection, this particular line here, but it's not quite that universal of a solution. The context has locators just for the models, so anybody can get them if we need to. So here in the view, we just get a reference to that model. Remember, that model is just holding the string of what the on-screen message is. Then we're going to do the binding here. So if the data model for the message changes, then we're going to listen back to that below. So anytime the data model changes, we will hear it. And anytime the view changes, we're going to listen to that. So down below, we'll look at the method for each of them. But remember, we're listening if the model changes or if the view changes. So down here, let's look at this one first. If the data model changes, then we'll update the view. And down here, if the view changes, then we'll update the model. So each of these two just do the opposite end of this two-way binding, and that's it. So the nuts and bolts of this particular flow are not unique to Mini. You could do that outside of Mini, but the classes that help it all happen are included in here. And it's especially an interesting topic when we talk about Mini MVCS, because data binding is a major plus. If you have data binding, then using something like Mini MVCS is even quicker and easier to set up. So let's run the demo one more time. I think I uncommented something. That's why we're recompiling there. So here again, we're running. We load from the service, the edit this text. Actually, that was hard-coded. We have the hard-coded value. And if I type into the left side, we get that. And if I say hi on the right side, it's synced. So that's it. That's data binding inside this Unity MVCS demo. We're done with that one. Just clean this up a little bit. So let's take a look at, oh, wait, that was my data binding demo. Okay, we did that. Okay, let's take a look at a demo of the Mini MVCS system and how you can have multiple minis in the same project. Now, why would you need to do that? It is a great question. I needed to have a drink of water just to think about it. So typically in a project, the reason that you bring on an off-the-shelf architecture like MVC, or specifically in this case, the Mini MVCS framework, is that you want to set your project up to be more maintainable and more scalable as the project grows. Now, the first thing that you would do is create the Mini structure, and inside of it, the model, view, controller, and service. Most of our demo projects have that level of complexity. If you want to add a bit more complexity into the project because the feature set grows, you could add another model, another view, another controller, another service, right? So you could have as many of those concerns as you want, all within the same Mini. But you could also, another tool that you have at your disposal is to have multiple minis be in the same project. So imagine a game where the core game loop, let's say we're playing Pac-Man, taking the input of Pac-Man moving around, grabbing the power pellets, the AI of the enemies, all that core game logic could live in one Mini, and you complete your whole game that way. And then you say, well, now we need to make a meta loop around the entire thing. We need to have multiple worlds. We need to have some social features. We need to have multiplayer. We need to have high score tables, whatever you're going to wrap around the core experience. You could add model view controller for that, or you could create a separate mini that is the meta game, and then you could have the core game mini and the meta mini talk to each other in a predictable way. So there's lots of different ways that you can scale up your project once you get Mini MVCS incorporated into your project. So we'll take a look at a demo of multiple minis in one demo project. So this is part of a course, which is the MVC architecture for Unity course. MVC stands for model, view, and controller. The high level content is here. Even deeper looking at the course content, we can see that we've got different sample projects. So the course goes over how to create a simple clock, how to create a login, how to have the roll a ball Unity demo where you have a ball moving with physics, collecting different cubes done with physics and scoring points. It's a classic Unity project. It's done for you here in Mini MVCS in the course. And then there's a custom sample project as well. What we're looking at now is more demos that we've added on top of that. There's about 10 different ones, but the one we're going to focus on here is multi-minis. So let's take a look at that inside Unity. So here we are inside Unity. If you look at if you're in the course and you follow the course, you can download it that way. If you're in just grabbing the free code off of GitHub, then you'll have the Mini MVCS here in your package manager. And you just want to go over here to the samples and import the samples. And then you'll have access to all we're about to see. Now that's already done here for me. And if I look over here in the more folder, we have, we got multiple minis here, right? So that's the one we've got set up. So in the multiple minis, we've got, let's just run the scene to start with. So here we have a left mini, which is a view model controller on the left side of the screen, and a right mini, which is a completely separate mini. So if you followed along and seen previous videos in the course or previous videos from this topic on YouTube from me, you'll know that generally in each demo, we have exactly one mini. But for talking about how you could scale up and those options I mentioned just a few minutes ago, this demo shows two minis here. So notice they look kind of similar. One is about 50% of the screen real estate on the left, and one is about 50% on the right, and they have quite similar looking layouts and stuff. That was just to have kind of some similarities here for symmetry. But they don't necessarily need to be logically or semantically similar in that way. You could have one, again, that's just the core logic of the game and one that's the meta around it. You could have one that is about 10% of the user experience and another one that is 90% of the experience. You could have even more than two. You could have 3, 4, 5 minis inside of a project. You could imagine creating a Unity package that is a mini and distributing that. And then people who have a mini-based project or a non-mini-based project could bring that package in and everything could work. So you can think of minis as their own little world and a lot of flexibility in how you integrate them. So here, what we do is we can click the increment counter button on the left, and it is updating the counter on the right mini. Now, there's lots of ways you could structure this. It's a somewhat arbitrary example here to split this, but for the sake of demo, on the left, it takes input, and on the right, it renders to the view. So let's take a look at how this scene is set up. So here we have the world, which just hides the camera and the light, since that's not too interesting for our talk. Then we have the left view, which is the portion just shown on the left, and the right, which is the portion just shown on the right. Each of those are Unity UI canvases, if you care. Then down here, we have the multi-mini example itself. So this is a mono behavior that is the demo that gets everything started. And I just pass in a reference to the left view and a reference to the right view so that the demo can link them up together the way that it needs to. So let's start here by looking at the mini example. Let me zoom out a little bit. So this is a mono behavior. I take a serialized field of the left and the right. Then what I do, quite fundamental and important to this demo, is I create the context outside of the minis, and I pass the same context in to the left mini and into the right mini. Now, why is that important? The context, much like the typical word context in life, context is decisive. Context determines which options and possibilities present themselves as available to you. So if I pass the same context into the left and to the right, they're able to communicate to each other. They can, for example, send commands to each other or get a reference to the model for each other. They're basically living in one world. If, for sake of argument, I had a context 1 and a context 2, and I passed 1 into the left and 2 into the right, then left and right cannot talk to each other, right? That's part of the encapsulation of how object-oriented programming work, which is reinforced in how Mini works. But if you want to be able to communicate, then you pass the exact same one reference to both, right? So let's look at the example on the left. Takes in that left view, takes in the context that we just discussed. And it will do the initialization. So let's see how the initialization works. So what it does here is, let's see, there's different options that I mentioned here in the comments. You could do different things. But what I do here is I create the model here inside. I pass that universal context into the model. Then I pass the context into the view, and then I create the left controller. So let's take a look at the left controller. It's going to take a reference to the model and the view. Remember, model is dumb data storage, and view is dumb rendering to the user and taking input from the user. And down here, all I'm going to do is say, hey, left view, anytime the user clicks that increment button, let me hear about it. Then down here, when I handle that, anytime you've clicked the button and we've heard about it, I just update the view. Sorry, update the model. So by adding that value there. Now let's take a look at the right, what did I say? The right mini. So here I am with this, here we're back here. So the left one we saw takes the click and updates the model. Now let's look at the right one. So it's going to store the right view in the context, same as before. Now it's going to do something a little bit different. Instead of creating its own model, it's going to say, hey, context, do you already have a model with this particular name? And we know we do because the left one just created it. And here we're going to say, hey, right view, here's your context in case you want to listen to that universal shared context. And then we create the right controller. Let's take a look at that. Now the right controller here is going to, now remember the left controller said, hey user, did the user click the button? This one says, hey model, did the model change? And then down here, if the model changes, it's going to send out a command. So we've got different examples about how command is useful and how view can talk directly to the model. So throughout these demos, as you're looking at them, you'll often see I have different options that are communicated. So here in this demo, what we're doing is invoking a command. Now in the series, if you look at commands, you can think of a command is a reusable set of instructions that's sent through the context. And any concern that wants to can say, hey, I want to hear anytime that command happens. And in this case, I'm invoking the counter changed command. And if any of the contexts want to hear about that, they can. So that's it for this demo. Let's take one more look at just running it. So again, the left side here takes the input. I'll click the increment button, 1, 2, 3. And the right side renders the output. So it's going to show the value of the model on the right. That's it. Do a little bit of cleanup here. All right, let's talk about how you would do an in-game tutorial in something. First of all, why is having an in-game tutorial useful to the end user experience? And why is it challenging for developers? Well, often when we play video games, there's enough rules about the game world, about how to interact, doing the input, that you have to tell the user about that explicitly. A tutorial is a device that in the first 1 minute, 10 minutes, 1 hour of gameplay, you give the user additional information. So as they walk up to a character, you explain how to hit a button to start the conversation. Whereas after 5 hours of that game, you wouldn't need to show them every time. So this is something that is temporary, often done at the beginning or the first time the user encounters something. So that's why we want to have it, right? Now, why is it challenging? Well, because it doesn't always happen, like typically when we create game features, they're always available. Here we want this only to happen in the first minute or 10 minutes or 1 hour, as I mentioned. So you could either go through all of your game systems and have them each say, hey, if we're in the first 10 minutes, do this extra thing, but otherwise don't do the extra thing. But that becomes a bit of code that you have to put in a lot of different systems. So what we're going to see here is how to do in-game tutorials in a different way. We're going to have the core game logic know nothing about the tutorials, and then we'll have a tutorial entity sit off to the side and listen to what the core game is doing, and it is only going to be active for the first 10 minutes, and then if it goes away, the core game never knew about it and doesn't know about it anymore. So let's take a look at how that would work. Now, this talk and this demo scene is part of a larger course, which is the Mini Architecture for Unity course that you can get linked below. Now, that's a paid course where you get to see samples on how this feature works, about the theory of software design. Here's an in-depth look. Looking at design patterns, looking at design principles, learning UML diagramming, covering different types of Unity architectures and why you might need them. The spoiler alert here is that you want them because they help you scale projects, create more maintainable code, and have more error-free workflows as you're building a project that scales. It includes lots of different stuff. One thing we've added here is 10 or more additional demos since the course was first created. And one of them is how to do a tutorial. And that's the one we're going to look at now. So let's jump into Unity here. So if you get the Mini Mvcs package free from Git, or as part of the course, you'll download and install that with the Git instructions. And then here in the samples tab, you'll import the examples. And that's what we're going to be taking a look at here on the side. Now, I've already done that. So when I go more, and then I open up the tutorial mini, we can see we've got some prefabs, we've got the scene, we've got a bit of code here that has the tutorial view and the tutorial controller. Let's go ahead and run this. Yeah, I'm actually going to show something before we step into this, because notice the tutorial. Well, I'll just make it nice and big. So the tutorial that is in the scene is in the box in the upper corner there. It says tutorial, enter username and password. So here, for simplicity, I'm mimicking how a web experience would work. Often we're logging in to web experiences. You have a username and a password. That is the core real estate of the screen, is the login mini example. Now that example sits in a different scene to just illustrate how separate this tutorial and the core game logic can be. I have the login mini as a separate scene. So that's a scene you can go and look at in depth, and you can see how mini can be used to put a username, password, login button, logout button in there. So it's telling me here that the password is 1234. So if I go ahead here and I type in the name, I'm going to type in my name like that. Then I'll start typing in the password. If I type in pass, notice as I start typing, the tutorial knows. So it first tells you, hey, go put in the username and the password. But the moment you've done the username and you start typing the password, it's like, oh, you might be ready to click login. So this is an arbitrary example about how the tutorial is looking into your progress through the core user experience and giving you some helpful hints. It could say, hey, here's a character you can interact with in the game. Click A to start dialogue. And after the user is familiar with that, you never want to show them the click A to start dialogue again, right? Same thing here. This is sitting off to the side, showing information. This could be available perhaps only temporarily through the game. But the core idea here is that the game itself doesn't know about the tutorial, right? Then I click login, I get failed. It says you failed the tutorial, try again. So I'll log out, and then I'll use the pass 1234, which is as the hint shows, is the real answer. I'll hit login. It says you completed the tutorial. So see how nice that is? The tutorial sits off to the side and gives you helpful hints. It could certainly give you much more hints than what's shown here. Let's see how that structure works. So here we have the tutorial view, which is the UI here with there we go, the title and the body. So it's just sitting up there in the corner, simple Unity UI. Then the mini here is going to take in a reference of that view, which we got right here. And let's take a look at how the mini is structured. So there's a comment here, I'll just read it. The example is the main entry point to the demo. A tutorial does not need to load a separate scene. That's done here only to demonstrate that this is a completely unrelated code that can properly decorate a user experience on top of a system without knowing. So we could have everything be in this scene, but I'm showing like, hey, if we load that login example, this can be so separate that it can be laid on top. And just that illustration of separation is nice, right? So here we'll take in the view. Now, most of the demo scenes that come, in fact, all of the demo scenes except this one, that come in with the mini are one scene demos. But here, again, after I load up the mini, I go ahead and I load in that login with mini example, which is just the login portion. And it was created long before this demo, and it knows nothing about the tutorial operating on top of it. It didn't even need to be updated for this. Then down here, what I do is make a bridge to the mini. And then I do the wiring up here. So controller and see how it works. So what I do is I update the tutorials little window to say the word tutorial, just to kick off the clarity there. And then I start listening in to the login model. So remember, I load that extra scene. I grab the model from it because it was created using Mini. So I'm able to grab the login model from it. And then I listen to a value called can I log in? And then I listen to some different commands. So anytime the login button becomes enabled, can login is true. So I'm able to listen for that so that I can step through the process. Then anytime the log out command happens, anytime the login submitted happens, and anytime the login completed happens. So there's 4 things that I've been able to listen to. Now, in theory, if you're developing the tutorial and the core logic at the same time, the step would be like this. Once you get the basic structure we have here, let's say that you had introduced the idea of walking up to and talking to characters in an RPG game. You'd want your core login model here to expose an event like started conversation with character equals true, or here's a new command that says the start conversation command. Either of those, you'd want to have them as part of the core game logic and be updated and dispatched. Then the tutorial out here can hook into that, as we see here, either through the model or through the context command manager, and be able to listen to those things. So the usefulness here down here we see that anytime the log out happens in the core logic, I will update the tutorial text to be its first phrase of, okay, it's time to enter login, enter username and password. Anytime can login is changed, which because the core logic knows should we be able to log in at this moment or not, the tutorial updates itself again and says a little bit more information. Anytime the user has submitted to log in, the tutorial will say waiting for the result. And anytime the login is finished, it listens in and says, well, if you were successful, then you're successful in the tutorial. Or if you were not successful, then you failed the tutorial. So it's an arbitrary demo here. This is kind of a silly example to give help for a form like this. But you can imagine in a game, there might be many different parts of the core logic that you would want to expose to the tutorial system. So two different teams in theory, just again to illustrate the separation, could work on one could work on the core game logic and one could work on the tutorial logic, as well as other systems. But I'm just showing about the separation here. And they're all speaking through the login model in the commands. So that's it. Now let's take a look at the demo running again. So again, bulk of the screen real estate is loaded from another scene. It knows nothing that it's been loaded in the tutorial. The tutorial sits on top and has just a little bit of view in the corner there and shows, well, it's the tutorial, enter the username and password. So I start typing in there and it updates. It says, okay, click login. Now I click login. It said waiting for result, and then it says, ooh, you failed. And I click log out. Notice the tutorial changes again. Now I can type some stuff in, and then I'll type the correct answer here, 1, 2, 3, 4. Click login. It says waiting for result, and then it says you completed the tutorial. So it's as tightly integrated as if it was part of the core logic, but you gain the benefit of that separation. So in the earlier part of this video, I mentioned one of the benefits of that tutorial being separate is that maybe you only want it to run for the first 1 minute of gameplay. I could simply disable the tutorial up there in the corner, and the core game logic doesn't need to know about the tutorial. It doesn't need to know if it's enabled or not. Or imagine that there's a settings menu, and the settings has check this box if you want the tutorial, check this box if you don't want the tutorial. So that also could enable that little window in the corner here to be toggled on or toggled off. Great. So that's it for that demo. Let's do a little bit of cleanup here. All right. I'm going to take a short break just to grab some coffee. All right, so welcome back. Here we're going to take a look at a demo of using Mini MVCs, which is an architecture for Unity, and using it along with UI toolkit. So this is part of a course that's available for pay, MVC architecture for Unity. It covers model, view, controller, and the link is below. You can find out more about the course, see if it's for you, watch the trailer for it as well. Here, we're going to be talking about more content that's added on top of the experience. So in the core course, we cover Unity, software design, all different aspects, Mini MVCs for Unity, which is one particular framework that I recommend, and all the different sample projects along with it. What I've done here is added even more demos. The course recently reached 6,000 or 7,000 students, which I'm super excited about. So I've added lots of new content on top of it. And what we've got here is one demo about using UI Toolkit. So UI Toolkit, if you don't know, it is the newest. It is now in Unity 2022 and beyond, the default UI that comes in, not in a package, but built in. And it's not the most popular yet. Unity UI continues to be pretty popular. It's been around for 5-6 years. But UI Toolkit is an incredibly powerful new system for doing all your UI. So we're just going to take a look at an example here of using UI Toolkit in the Mini MVCs project. So let's take a look here. Here we are inside the project, and this is the Mini MVCs free repo that is available on Git. There's a link in the chat, link below that you can take a look at. And in it, you can click the samples and import the samples here and follow along. Now that's already been done here for the sake of this demo. And we can see here in the more folder, we've got all sorts of different stuff. And the very last, the 10th one that we're gonna have covered in the series is the Mini incorporated with UI Toolkit. So here I've got, let's look at all the different stuff we've got. We've got a resources folder that's got some stuff inside of it. We've got the scene, which I'll run in a moment. And then we've got the source code. Notice the source code in best practices for Mini. It is divided into controller, model, service, and view. So let's go ahead and run the Mini. Load that up. And let's take a look at playing this example. So here we have UI. If you're not familiar with UI Toolkit, you may think, oh, this is created in the normal Unity UI. But let's take a look at how it's structured. So each of these elements here is a button. And notice that they have a consistent mouse over. Really nice. And I'll click a hair button and it changes his hair. Click a face button. The shirt button. It's just stepping through some different graphics. The body itself can change. You can randomize. And you can reset to the original. Now, the entire UI here is created in UI Toolkit. So we'll take a moment and look at that. And then we'll jump in and we'll focus on the Mini experience. So let's look at the scene structure here. So here in the world, let me close this up. Yeah. So here in the world, we just have the main camera and the light. Nothing too exciting there, so I just put them in that empty world object. Then we have the view here, which is the UI Toolkit view. We'll look at that in a moment. And then we have the example for the Mini itself. So there's two parts to showing this demo here in this video. There's the UI Toolkit part and then the Mini part. Now, actually, if you're familiar with Mini, there's really nothing new happening here as far as how that structures work. So we will take a dip in there, but the interesting thing here that's kind of new for a lot of Unity users is just how the UI is set up. So what I do here is I have a UI document, which is right here. And UI document is a core Unity class. Let me pop myself over here for a second. The Unity UI is a core class, part of UI Toolkit, and it takes a visual tree asset. So if we look at our project here, I already lost where I clicked that. Click. Click. There we go. So in this UI Toolkit mini demo, there is a UI Toolkit folder, and it has some settings in it. It has the cascading style sheets, which are called USS. It has the UI Toolkit layout. Now it's the layout that determines what's on the screen. Now I have other videos linked below, and you can take a look at how UI Toolkit works, how and why it's super cool, how it's based on web standards like CSS, HTML, and JavaScript. But let's just open this up so you can take a quick look. Make it full screen here. I'll click this. There we go. So we can see here, let me see which side is better for me to be on. I'll pop back over here. So you can see here, it looks kind of like the whole Unity editor here in what we're looking at, but this is actually one layout window inside Unity because the UI Toolkit system and its UI Builder window here has lots of information. We've got all the different styles represented on the left. We've got a hierarchy of the structure here that is just the hierarchy of the view. You can see we can click across all the different items. Remember, if I click preview here, I can see the different mouse over states. Let's just take a quick peek at what are the benefits of using USS. If I wanted to change this from getting bigger and turning blue as we mouse over, what if we wanted it to go smaller and green? Just for an arbitrary example. I've got a style here for when the button hovers. And if I go down here to the color, I'll change it green. And then I go down to the transform and I'll change it to 0.98 and 0.98. So now I'm going green and smaller. Now let's do the preview again and mouse over. Now look, all of those consistently change their over states. Now doing the same thing in the traditional Unity UI system is very possible, but it has never been more easy to have templated effects that go over the pseudo states of mouse hover, selected, etc. built in. Very, very nice. So the point there is that that system is super cool, but we're not going to go into depth with that. Let's now take a look at, we pop back over here. Pop back over here. We'll take just a minute here and go through how the Mini is set up. So in that scene, we create some of the Mini concerns. We create the context, the model, the service, and the controller. Now, as we've seen in a lot of other demos in the course, and you can watch different videos on YouTube about this that I've covered, the controller is really the glue that brings it all together. So let's take a look at how that works. So here what we do is we initialize and we say, hey, model, maintain an int that represents the index of which hair we've got on. And it'll be 0, 1, 2, 3, 4, depending on the hair. For the face, for the shirt, for the body. So all of those different elements are stored in the model and we listen to them here. And anytime the model says, oh, the user has advanced which body to use, we just grab the next reference to a sprite and we use that there. Then down here, anytime the view changes, so if we click the hair button, then we're going to handle that the hair button has been clicked. Anytime the face button gets clicked, we'll handle that stuff here. So we're handling changing things, affecting the rendering of the view and also listening back. Then down here, let's just see what happens anytime we click any of the buttons here. We go down here and we change the different value that is stored inside the data model. So if you click next hair, please, then it updates that inside the model. All right, so that's it. There's one thing that I did want to look at here, which if I go back here and I see that when I create the view, I don't create it here actually. Yeah, UI Toolkit view. So here we have a public property for each of the buttons in that UI. Now, typically you would have these be serialized fields for each button in Unity UI, but we're going to do something uniquely different here because we're using UI Toolkit. UI Toolkit has a query language where you can type .q and get any named element. And if you want it strongly typed, you can do .q button and then give it the name you want. So you can see here in that syntax that I'm able to get at the hair button. Now let's just look, double check where that's named. That's named in the layout itself. So when I brought up that big window and showed how everything is designed there, then you give them your own custom name, and here I use it. Now, sometimes you'll see them named like hair button, like that, borrowing from kind of a web world, web standards way, but I continue to use the Unity naming that I like that. So that's really the only other thing I want to show. Let's run the scene again. There we go. So I click hair, I click face, click shirt, click body, click the reset button, and everything works there. So it looked a little bit jittery there, but I think it's working really great. So thanks very much for watching this video, and that's it. Now we're going to just clean that up a little bit. Actually, I think that's the end of the series. That source code back onto YouTube. And if you really want to dig into the course, then take a look at the course itself, which is available. That's the Mini MVCS course. And that is Model View and Controller. And we cover the course introduction, everything about Unity and how Unity's fundamentals are structured. We look at software design and then the Mini MVCS for Unity as the leading architecture for the course. There's lots of extra content included. We've got over 10 or 15 sample projects that are included in that free repo, so you can take a look at them. So that's it. Thanks very much, and best wishes on your projects.